Hey there! So today we are going to solve another LeetCode problem named balanced binary tree. Easy level, so the video is going to be really short, and it goes like this. Given a binary tree, determine if it is height balanced. And the height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than 1. And there are some examples here. So in the first one, we see a little bit imbalanced tree. As you can see, the left subtree of the root goes to one level down, while the right one goes for 2 levels down. But the difference between those depths is no greater than 1, so the whole tree is considered as balanced. In the second example, we can see the greater imbalance. So the right subtree of the root goes down to one level, while the left one goes down for 3 levels. So the tree is considered as non-balanced. All right, so let's start to work on our problem. And first of all, let's think when are we going to consider any node of a tree as non-balanced. It could be either when one of its nodes is already non-balanced, or it could be when both of the subtrees are balanced, but the difference in depths between those subtrees is greater than 1. So let's create a type to represent our conclusion on whenever a node is balanced or not. Name it, for example, balance result. So it's going to be based on enumeration, and it could be either non-balanced or balanced. However, as I just said, if the subtree of any node is balanced, this information is not enough to also consider our current node as balanced. We also need some information about the depths of those subtrees. And as we are using Swift, we have an amazing opportunity to use the associated values. So why not to provide the depth as associated value for the balanced case. All right. Now, as usual, when we are working with the trees, we could create some kind of a recursion method which is going to check any node, and it's going to return our balance result at the end. Okay, so first of all, let's check that node exists. So if it does not, well, we can consider it as a actually balanced node, right? Because it doesn't have any subtrees, and its depth, well, let's consider that the depth of this subtree is 0. All right, so now we need to check both left and right subtrees of that, and they both should be balanced. So let's create a guard case for balance case. First of all, we are going to check the left subnode of the node, and then we're going to run this check balance also on the right subnode. Right. All right. So if any of these guard checks fail, then it means that one of the trees are non-balanced, and we could also say that our current node is non-balanced as well. Now let's check which depth is greater, the left one or the right one. And for that, we are going to create two variables, min and max depth. And if the left depth is less than right depth, then the mean depth is going to be equal to left one. Sorry. And the max depth is going to be equal to the right depth. All right. Otherwise, it's going to be the vice versa. So the mean is going to be the right, and the max is going to be the left. And finally, we are able to check the difference between the max depth and the mean depth. If it is greater than 1, then just return the non-balanced result for this node. Otherwise, the node is balanced, and we need to calculate the new depth. And for that, we are going to use the max depth, the maximum depth of its subtrees, and add one additional level, the current level, to the result. Right. So finally, we are able to run this check balance on the root to check if the whole tree is balanced. So if it is not balanced, we are returning false. If it is balanced, and no matter what depth it is, we're going to return true. Let's check for any compilation issues. Nothing here. And finally, let's submit our solution. Nice, nice. So as you can see, the execution time of this solution is less than 1 millisecond. It actually stays somewhere on the edge of the threshold, and that's why it beats 100% of other submissions. And that's it for today. If you'd like to see me solving other LeetCode problems, then put your request in the comment sections. See you next time. Cheers.